we're reviewing for your logarithms and exponentials test coming up. First thing to do is we need to rewrite these, writing them as a logarithm. So this first one, 2 to the 7th power. Well, 2 to the 7th, first of all, has to equal a number. It equals 128. So to be able to write it as a logarithm, what I need to do is write out as log base, whatever this big number was, which was 2, of my answer, 128, equals whatever the exponent is, 7. Logarithm tells you an exponent. Okay, same thing here. 5 to the 4th equals a number. 5 to the 4th equals 625. So that means when I do my logarithm, it's log base 5 of 625 equals the exponent 4. Then the last one here, 10 to the 5th, or 4 to the 5th, I mean, equals 1024. So that means that I have log base 4 for the big number of 1024 equals the exponent 5. Alright, same going the other way. To rewrite them as exponentials, I write 3 to some power will equal 81. What is that power? The power is 4. With this one, there is no number. Remember, when there's no number, we assume it's base 10. So 10 to some number equals 100,000. That number is 5. 1, 2, 3, 4, 5 zeros. And the last one, natural log means e. So e to some power equals, notice on the inside, which is e to the 7th. Well, the bases are the same. The only way that can happen is if it's e to the 7th. So it kind of looks redundant, but that's all you need to write for that one. E to the 7th equals e to the 7th. Alright, for these kind, actually solving them, what we first need to look for are the bases on both sides the same. If so, I can just get rid of them and set the exponents equal to each other. So 4x minus 7 equals 3x plus 8. Subtract 3x over and add 7 over. I should get x equals 15 for my answer. For number 8, the bases are not the same, so I need to ask myself what's the number I can raise to get to 25, raise to a different power, get 125. The answer there is 5. So it's 5 squared gets you 25, and 5 cubed gets you 125. Okay? And then what I do is, whatever my exponents were, so this was 5x minus 9, and this one was x plus 12, all we're doing is we're literally multiplying those exponents together. So I end up with 5 to the 10x minus 18 equals 5 to the 3x plus 36. And again, now that my bases are the same, my exponents have to be the same, so all I have to look at is 10x minus 18 equals 3x plus 36. Okay, I should subtract over, I should get 7x equals 54, which means x equals whatever the fraction is, 54 over 7. Okay, and number 9, again, we're already given bases are the same. The base is e, who cares what it is? I could make up a number, make up a letter, and it would have to be the exact same. So I just set my exponents equal again. 10x minus 14 and 6x plus 2. Subtract over to get 4x, add over the 14 to get 16. That means x equals 4 is my answer. In number 10, I need to first get the exponential alone. There's the exponential. To get it alone, I need to first subtract over this 4. So 7 to the x minus 2 equals 108. Now, the next question, kind of like we did in number 8. Is there a number I can raise to a power to get 7, raise to another power to get 108? There is not such a number. So what I need to do is the inverse operation, which is a logarithm. So log base 7, is the big number 7, of both sides. When I do that, the log base 7 and the 7 cancel out, and I'll be left with x minus 2 is equal to whatever log base 7 of 108 is. So to get x by itself, x is log base 7 of 108, and then to get that 2 over, I would need to add 2 to both sides. This is the most exact answer. Now, if I wanted to type in and get a decimal in my calculator, I would do log of the big number, 108, divided by log of the little number, which is 7, and then add 2 to that. And my final answer when I would do that is 4.406 as a decimal answer. Okay, looking forward, same things going on down here. I'm going to start the same way I just did with number 10. I'm going to subtract the 2 over, so 4 to the 3x minus 1 equals 64. Now in this one, I'm going to ask again, is there a number I can raise by power to get 4 and 64? Yes, it's just 4. So the first one stays the exact same, and I can write 64 as 4 to the third power. Now I can just set those exponents equal to each other because the bases are the same. So that gives me 3x equals 4, or x equals the fraction 4 over 3. Okay, and number 12, a common mistake. A lot of people will try and divide by 6 right away. You can't do that. There is no number either that we can raise to a power and get 6, but raise to a different number to get 24. So all I'm going to do is I'm going to do a log of both sides, log base 6 for both, because the number there is 6. So when I do that, the log base 6 and the 6 cancel out. We're left with x plus 3 equals log base 6 of 24. So that means x as an exact answer is log base 6 of 24, and then subtract 3 from it. In your calculator, that's log of the big number 24 over log of the little number, which is 6, and then subtract 3 from that, and I get as a decimal answer for that, negative 1.226 for the answer. In 13 down here, first step is I need to make sure again the exponential here is by itself. I'll do that by dividing both sides by 2. Now the big issue is you cannot divide the exponential by 2. You need to just essentially get rid of just the 2 by dividing both sides by 2. Not every term. So 14 divided by 2 is 7. Okay, and now the same thing. There's no number I can raise by a power to get both 10 and 7. So I'm going to take a log of both sides. Log base what? Base 10. But we don't write base 10 because that's our normal operating system. So we're just going to do log of both sides. Now leave me with when I do that. 2x minus 7 will equal whatever log of 7 is. So to get x by itself, I would first add 7 and then divide by 2. So log of 7, add 7 more to that, and then divide by 2. And my numerical answer when I do that is 3.923 when I punch it in the calculator. Alright, in 14, a number that I can raise to a power and get 9, and one that I can raise to 1 over 81. A lot of people will think, well, there really is no such number. Well, there really is. Okay? The number is 9. 9 to the, well, 2x minus 6 is the exact same. Now, 9 to what power would give me just a regular 81? Well, that would be 9 squared. However, because it's flipped over a fraction, I make the exponent negative. And now I have the bases the same, so the exponents are the same. So 2x minus 6 equals negative 2. 2x will equal here, should be a positive 4, which means x equals 2 is my final answer for number 14. Okay, in 15, already we're looking at, well, we have a base of e, so I'm going to be having to do the natural log of both sides. When I do that, it leaves me with 10x equals natural log of 100. To get x by itself, divide by 10, natural log of 100, then divide by 10. And that is numerically, when I punch it into a calculator, 0.4605 or 0.461, something along those lines. Okay, in number 16, I have two things over here. A lot of people will try to take a log immediately. You can't do it until we have like bases everywhere. So, what we're going to look at, 4 to some power, or 4 is equal to some number to a power, 2 is the same number to a different power, and so is 1. Now, you can see definitely with these two, I can make 2 squared to give me my 4 to the x plus 1. So there's that part. I already have the 2, because it's already the same, 2 to the first power, so 3x minus 2. However, 2 to what power gives you 1? Well, any number to the 0th power gives you 1. So there's your exponent there. Your exponent should be 0. So now I can just set those exponents equal. 2 times x plus 1. And then when I'm multiplying, that means I need to add my exponents together. So plus a 3x minus 2 equals the exponent over here is 0. So 2x plus 2 plus 3x minus 2 equals 0. That means 5x equals 0, which means x equals 0. Alright, so now moving on to the last step, the logarithms. And we start the same exact way we did before. If we have two logs that are the same, so natural log in both cases, that means I can just ignore them and look at what's on the inside. 12 equals x minus 7. Add 7 to both sides to give you 19 is equal to x. Number 18. What we want to try to do first, there's a number out in front, so let's first look, can I divide? Well, dividing gives me absolutely nothing, so I'll ignore dividing. The other option, though, when I have a number out in front, that's the same as if it was on the inside as an exponent. So I can rewrite this as log base 4 of x squared equals log base 4 of 49. So now I have two logarithms by themselves. They're both of the same base, log base 4, so I can just ignore them and look at the inside. X squared equals 49. That means x should equal, when I take the square root, it should be plus or minus 7. Now here's a side note to look at. Based on what the original problem was, I would have to do log of -7. I can't take log of a negative number, so technically the answer should just be +7 right there. It's a little bit of a tricky one, but I'm more worried about the algebra part from it there rather than some extraneous solutions at the moment. Alright, in number 19, I have a 3 on the outside. Can I divide both sides by 3? It looks like it, so I'll do that first. So ln of x minus 2 equals whatever 72 divided by 3 is, which is 24. I'll now want to get rid of the natural log. I'll do that by making those the exponents with both bases being e. That way, the ln and the e cancel out, and I'm left with x minus 2 equals e to the 24th. To get x by itself, x equals e to the 24th, and then add 2 more onto that. And that's a huge number. It's like 2.65 times 10 to the 10th power, a huge number. I'm more worried about this part right here that's more precise anyway. And in number 20, we already have the log by itself. Raise both sides with 3 being your base. Again, the logs and the raising to the 3 cancel out. 2x equals 3 to the 14th. That means x equals 3 to the 14th divided by 2. And you get, when you plug that into your calculator, 3 to the 14th over 2 ends up being 2,391,484.5 as your answer. Big number. Again, I'm mainly worried about, can you get to that point right there, 3 to the 14th divided by 2. Alright, your last one here, number 21, and 22 obviously. What we need to first look at, where are your logarithms? There are 2 of them, and they are on just one side of the equation. So I need to find a way to make that into a single logarithm. They're both base 5, which is good. When I have this subtraction, that means I can combine them, and the inside is division. Subtraction becomes division. Okay? And it equals 2 on this side. Still, what I want to do is raise both sides. The base is 5, so I'm going to make my base 5. When I do that, these cancel out. I'll be left with x over x plus 2 equals 5 squared, which is 25. And then I'm going to multiply this bottom to bring it up to this side. So I have 25, and now times x plus 2. Expand it to get 25x plus 50. Subtract 25x over. Now we're solving like normal. So that means x will equal 50 divided by negative 24. So my answer is negative 25 over 12. Alright, and my last one. First things first, I have an 8 out front. Can I try to divide both sides? I definitely can. So I'm going to do that. Log of 4 plus log of x equals 16 divided by the 8 is just 2. What I'll do from there is, again, I need to try to combine this into one logarithm. To do that, it'll be log of, over here when I subtracted, it became division on the inside. Now I'm adding them separately, so it'll become multiplication on the inside. Log of 4x equals 2. There is no number here, that means we assume base 10, so I raise both sides from power of 10. I'll leave now with 4x equals 10 squared, which is 100. That means, again, yes, 4x equals 100. X will equal 100 divided by 4, which is 25. Alright, a couple quick things I just want to point out as a little add-on side note, hint, hint. A couple things to really look at. First of all, if I am doing any number, so 4, 7, 3, 5, 2, doesn't matter. Anything to the 0th power always equals 1. In terms of a log, that would mean that I write it as log base 4, 7, 3, 5, 2 of 1 equals 0. Whatever this number is, if you're taking a log of 1, I'm going to have an answer of 0, because 0 has to be my exponent here. Okay? Remember, ln means that we're taking log base e. If I'm writing just log, that means we assume it's log base 10. Okay? And then again, just kind of like those rules we just did. So if I do log of 5 plus log of 9, that means we'd have log of 45. We multiply. If this was minus, that means it would be log of 5 over 9. The other one, if I have 9 times log of 5, that's the same as doing log of 5 to the 9th power. I can bring that up as a result. So remember those rules, remember just a couple of these little tricks, and you should hopefully be in perfect shape for everything you need to do on your test tomorrow. Good luck.